Hey friends, welcome back to my channel TechSage Academy. So in our previous video, we have seen the working of for loop. In this video, we will be covering while loop in detail. We will also be looking at the nested loops and the concepts of continue and break statement. So let's dive into the programming and start working with while loop. Now the next type of loop that is available in Python is while loop. All the things that we have done with the help of for loop can be done with the help of while loop also. Let's see how while loop works. Now, while loop executes a set of statements until and unless a given condition is true. As soon as the condition becomes false, the loop terminates. This is how while loop works. That means it is provided with a condition in its header part. That condition needs to remain true so that the loop can continue to execute. As soon as the condition becomes false, the loop is going to terminate. The syntax of while loop is while within brackets condition followed by colon. Now colon again indicates the start of block. Now whatever statements are written within this block of while loop will execute as long as the condition remains true. Here are examples of while loop in which we are displaying values from 1 to 5 and using different step values just like for loop. So let's try to understand them programmatically. So this was the for loop. Now we have to use while loop. In the first loop, we are going to display values from 1 to 5. Now there are few basic differences between a for loop and a while loop. In for loop, the counter variable was given within the header part of the loop for I in range. So the counter variable I was given in the header part itself and it was initialized automatically. But for while loop, we have to do it differently. For while loop, we have to declare the counter variable before the loop starts. So here I'm going to declare the counter variable I is equal to 1 and I have initialized it on 1. One thing that we should remember is we can use any valid variable name. It is not only I, j, k. We can use any valid variable name for our counter variables. But there has been a convention which is being followed for so many years that in programming languages counter variables are declared as I, j, k and single letters like these. So that's why we are taking I. So I is equal to 1 while. Now while is a keyword which marks the beginning of while loop. Now we'll write the condition while I is less than equal to 5. That means till the value of I remains either less than or equal to 5. As soon as it surpasses this value, that means it becomes 6. This loop will terminate because the condition becomes false. So colon and print. I'll print a message again. Value of I. Second difference between for loop and while loop. The counter variable in for loop was incrementing automatically. That means automatically it was going from 1 to 2, 2 to 3, 3 to 4 and 4 to 5. But here in while loop, we have to increment the counter variable explicitly. It cannot increment itself automatically. Auto increment does not work here. So I is equal to I plus 1. This is the explicit incrementation for the counter variable. Now let's run and check the loop. And you can see the output is same as the for loop. Using different step values, like in for loop also we have used a step value 2. So let's use a different step value here also. So here instead of I is equal to I plus 1, I'm going to change it to I is equal to I plus 2. So the first value of I is initialized at 1. Now the next increment that takes place in I is equal to I plus 2. Value of I becomes 3. Then the next increment that takes place in I is equal to I plus 2. That means 3 plus 2, 5. And 5 plus 2, when it becomes 7, the condition is checked and the loop terminates. So it works something like this. First of all, initialization takes place. Then the condition is checked. If the condition is true, the loop executes. Within the body of the loop, the incrementation takes place. After incrementation, again the control goes to the condition. If the condition is true, the loop executes. Again incrementation takes place. Again condition is checked, and this process goes on till the condition written in the header part of while loop becomes false. This is how while loop works. So I've changed the step value. Let's run this and check this loop. And you can see the output 1, 3, 5. Let's display the results or use the reverse order. Display the values from 5 to 1 using while loop. Here's the example. Let's do it programmatically. So this time I'm going to initialize I on 5. I'm going to change the condition while I greater than or equal to 1. And here in incrementation part, I'll be decrementing it. So I is equal to I minus 1. First, the I is initialized on 5. The condition is checked. Condition is true. It is greater than 1. The loop executes. Now the decrementation takes place. Decrementation 5 minus 1, 4. Again, condition is checked. Loop executes. Decrementation 3. Condition checked. Loop execute. Decrementation 2. Condition is checked. Loop executes. Decrementation 1. Condition is checked. Loop execute. Decrementation 0. Condition is checked. The condition becomes false this time because 0 is not greater than 1 and the loop terminates. So let's run this program. And here you can see the output. This is how while loop works. Now let's talk about nested loops. Nested loop is the concept when we give one loop inside another loop. For example, a for loop is given inside for loop, while loop is given inside while loop, for loop is given inside a while loop is given inside a for loop. So all these permutations, combinations, when we give one loop inside another loop, it becomes a nested loop. Now, how this nested loop works? Now, the loop that contains a nested loop is called a master loop. And the loop which is present inside the master loop is called either nested loop or inner loop. What are the steps for execution of the nested loops? Number 1, the master loop starts. Master loop starts, the statements written inside the master loop executes, and then the control goes to the inner loop. The inner loop starts. The statements written inside the inner loop will execute. The incrementation in the inner loop will take place. Then the condition of the inner loop is checked. If the condition is true or if it is inside the range, the loop executes. Again, the inner loop executes. Again, the incrementation takes place. If the condition is true or if it is inside the range, the loop executes. This process continues for the inner loop till either the condition becomes false if it is a while loop, or it remains inside the range or the range exceeds if it is a for loop. Once the inner loop terminates after executing all its passes, remember, once the inner loop executes completely after executing all its passes, the incrementation in the master loop takes place. And after incrementation in the master loop, the control goes back to the header part of the master loop. And if it is a for loop, the incrementation will take place in the header part itself. Again, the condition of the master loop is checked. If the condition is true, The instructions written inside the master loop will execute. The control goes to inner loop. And again, inner loop will complete all its passes. The inner loop will terminate. The incrementation will take place in master loop, or if it is a for loop, incrementation will take place in the header. Again, if the condition is true or if it is inside the range, the control goes inside the master loop. The statements execute. Control goes to inner loop. Again, inner loop completes all its passes. Once the inner loop terminates, again the incrementation in the master loop takes place. Again, the condition is checked. This process continues till the condition of master loop becomes false, or if it is a for loop, the range is exhausted and the loop will terminate. The master loop will terminate. So this is the process of execution of nested loops. So let's see some examples of nested loops. I'm writing a nested for loop. That means for inside a for. So for I in range 1, 2, 3. So it is going to execute 2 times. This is master loop. In master loop, I'm printing a statement, print value of I. After printing the value of I, I'm going to start another loop. So for j in range 1 to 4, that means it is going to execute for 3 times. The block of j loop starts, print value of j and j. And just to give a distinction that the values of j are under the values of I, what I'll do, I'll use a tab key here. /t. /t is an escape sequence which is used to give a tab space. So I have used /t before value of j. So the value that is going to be printed, this statement is that is going to be printed, will leave a tab space and then the printing is done. So it gives you an impression that it gets printed under the i's statement where we are printing value of I. Let's run and you will understand. So here you can see, first of all, the loop of I starts. I is initialized on 1. Then the control goes to the loop of j. Loop of j starts and it completes all its 3 passes. Value of j1, value of j2, value of j3. It completes all its passes. Then the loop of j is terminated. The control comes out of loop of j and it again goes to loop of I. I increments, it becomes 2. And then the control comes to loop of j again. So again, the loop of j is executed 3 times, completing all its passes. All the values gets printed. The loop of j terminates and then the loop of I terminates. This is how nested loop works. Now let's try to understand this with the help of one more example. Let's say I'm going to enter 2 values, 2 numbers at runtime, and I want to display tables of all the numbers which are falling between those 2 values. For example, the first number I enter 2 and the second number I enter 5. I want my program to display all the tables of 2, 3, 4, and 5. Tables of all the numbers. And for this, we are going to use the nested loops. So let's say the first number is x. X is equal to int input, enter x. Y is equal to int input, enter y. For I in range x to y plus 1, because I want the tables of all the numbers x to y to be printed. So I'm taking y plus 1. For j in range 1 to 11, print I into j equal to I into j. And when this loop of j gets finished, I'm going to use one more print statement. It's a blank print statement, which will be used to give an extra line between two tables. Okay. Now, how this loop works? First of all, I is initialized on X, the number that we have entered. So let's assume it is 2. I is initialized on 2. The loop of J starts and will run from 1 to 10. That means 10 times it is going to run. The value of J is going to be changed from 1 to 10. And what we are doing inside this loop, we are multiplying value of I with value of J, I into J. So I is 2. It is multiplied by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the table of 2 will be displayed. Once this loop of J is terminated, the control come out of loop of J and this blank print statement executes. A blank line gets printed. And then I increments, it becomes, let's say 3. And again, the process repeats. So there will be an extra line between two tables. So let's run and check this program. So first number is 2. Second number is 5. And here you can see the tables of 2 to 5 gets generated. This is how nested for loop works. Now let's see the execution of nested while loop. So I is equal to 1 while I is less than equal to 2, print value of I. Then J is initialized. J is initialized inside the loop of while. J is equal to 1 while J is less than equal to 3, print value of J. Now incrementation of loop of J. J is equal to J plus 1. Out of the loop of J, increment the value of loop of I. Increment the value of I. I is equal to I plus 1. So how will this loop work? First of all, I is initialized on 1. Condition of I loop of I is checked. Condition is true. We enter inside the loop of I. Print statement gets executed. 1 gets printed. Then J is initialized on 1. Condition is checked. Condition is true. The loop of J will execute 3 times. And then the loop of J terminates. When it terminates, the control comes out of the loop of J and I increments. I becomes 2. The control goes back to the header part. Condition is checked. Condition is true. We again enter inside the loop of I. Statement gets printed. J is initialized to 1 again. And again, the loop of J will execute for 3 times. The control come out of the loop of J. I increments, I becomes 3. The condition becomes false. Condition of I becomes false and the loop of I terminates. So it is same as the first nested loop for that we have seen. Let me use /t here also and run this program. And we can make the same program, the tables program, that X is equal to int input, enter value of X, Y is equal to int input, enter value of Y. Now the loop of X will start while X is less than equal to Y. And within the loop of X, I'm going to initialize loop of J. J is equal to 1 while J is less than equal to 10. Print X into J equal to X into J. J will increment. J is equal to J plus 1. And out of the loop of J, X will increment. X is equal to X plus 1. Now let's save and run this program. X is equal to 2, Y is equal to 5. And here is the output. All the tables between 2 to 5 gets printed. This is how loop of while works. Now we can nest these loops one inside another. That means for loop inside while loop inside for loop. And this nesting can go on to any level. Here is an example where we are nesting while loop inside for loop and for loop inside while loop. So I think you can try out these programs easily. Let's move on to the next topic, and that is break statement. What is break statement? Break statement is used to jump out of a loop if a condition is satisfied. On meeting a certain condition, we can break the loop even before it completes all its passes. We can break the loop and come out of the loop, and our rest of the program will continue. So let's see how this break statement works. So S is equal to Python for I in S. If I is equal to H, since I is going to take up all the values one by one present inside the S string, as here I is working as an iterator object. So if I is equal to H, break, and out of this if condition, I'm going to print I with end is equal to space. Now, if when we are using this end parameter inside the print statement, the printing is done in the same line. So let's run this program, and you can see PYT. As soon as the value of I becomes H, the condition is satisfied and the loop is terminated, and we have come out of the loop. The loop is terminated. PYT only gets printed. So this is how break statement works. You can use this break statement inside while loop also. So let's use it in while loop. I'll just change this loop, but I'll be using few different things, since for while loop to work inside sequence types, we need index values of these sequences, because while loop cannot create an iterator object like a for loop. And that is the speciality of for loop. It can create an iterator object. A while loop in Python cannot create an iterator object. So what I'm going to do, I'm going to take a counter variable I is equal to and initialize it to 0, because the index value of a sequence type starts from 0. While I is less than equal to, now I don't know what is the length of Python, this sequence. So what I'm going to do, I'm going to use length function and length of S, pass S as parameter. It will automatically fetch me the length of the string, colon. Now the length of the string is 6 and I is initialized on 0. And if the loop runs from 0 to 6, it will execute 7 times. That means in the end, this program will generate an error that index is out of bounds. So instead of using I less than equal to, I'm going to use I less than length of S. So less than 6, it is 5. So 0 to 5, 6 times the loop is going to work. Now, if, and here I'm using this counter variable as a subscript. If S within square brackets I, here I works as a subscript. We have given it with the string S within bracket I. So it works as a subscript or index value. And what we get the element stored at that index position. So at the 0th index position, P is stored. At first index position, Y is stored. At second index position, T is stored. At third index position, H is stored. Fourth, O, and fifth, N. So we will get those letters. So when S within subscripts I becomes equal to H, that means it fetches the element H, the loop will terminate. And what we are going to print here, we are going to print S within subscript I. One by one, each and every character that is going to be fetched. But since as soon as the element becomes equal to H, this loop is going to break. But we know that we need to do explicit incrementation in while loop. So I is equal to I plus 1. Let's run it. P by T. Same output. So this is how the break statement works. Now, next important part of any loop is continuous statement. What is a continuous statement? Continuous statement is used to skip the current pass of the loop which is executing. The break statement was used to break the loop. Continuous statement skips the current pass of the loop, and the loop continues from the next pass. The current pass is skipped and the loop continues to execute from the next pass. So let's see how this continuous statement works. S is equal to Python for I in S if I is equal to H continue. Instead of break, I'm using continue here. And then out of this if block, I'm writing print I and is equal to space to get the output in the same line. So how this loop works here? When the value of I becomes equal to H, the if condition becomes true, we enter inside the if condition and continue statement executes. And the current pass of the loop is skipped. And the control goes back to the header part of the for loop and it continues from the next pass. That means H is skipped. It continues from O. So the output that you will get in this case will be P, Y, T, H is skipped, O, N. Let's run and check this program. So P, Y, T, O, N. This is how continuous statement works. So friends, in this program, you have seen how the iterative statements works. For any good program, these three components of flow of control are very, very important: sequence, selection, and iteration. We have learned sequence, we have learned conditional statements, we have learned if conditions, variations of if conditions in our previous episode. In this episode, we have learned iterations completely. Now it's up to the demand of the program, requirements of the program. How do we use these flow of control components inside our program? So I hope I've been able to explain it thoroughly, properly, and you are able to understand these concepts. Please subscribe to my channel, share this video, comment in the comment box below, and click on that bell icon so that as soon as I upload any new video, you should get the notification. Till next video, take care.